Okay, the purpose of this video is to review for the midterm exam, but also to use it for review at any point in the course before taking one of the bigger exams. So we're going to start off just using the standards that have been set up for this class. So the first one, C.1.1, is understand the concept of a limit and estimate limits from graphs and tables of values. So for example, we want to estimate the limit as x approaches 2 of x squared plus 2x minus 8 all divided by x minus 2 by calculating the function's values for x equals 2.1, 0.01, and 0.001, and for x equals 1.9, 0.99, and 0.999. So that right there kind of gives a hint of what the idea of a limit is. We want to find out the behavior of a function as x approaches some number, gets really close to it, but is not quite equal to that number. So it's kind of like, what is the function's intention as it gets close to that number, but some things can happen at that number that render the function non-existent or what have you, but behavior in and around that spot, very close to it, is what we're interested in here. So we want to see this graph, the graph of this thing. We notice that it's a squared function divided by a first degree, a linear function. So what this is going to look like is a straight line, and it looks like any ordinary straight line. However, if you look at the function again, we notice that in the denominator we have x minus 2. Well, we know that if we substitute 2, that's going to make that denominator 0, and there should be the value should not exist there. So the function doesn't exist at 2, and yet the question we're looking at is actually trying to find the limit as x approaches 2. So we want to find out what the function is doing around 2, since it doesn't actually exist there. Alright, so I brought a table of values up to the right here, and I see at -4 we have 0, so that is here, and -3 the value is 1, -2 the value is 2, so on and so forth. So if I keep scrolling, I can see that at 2 it's undefined. What we want to do is we want to use estimation, or use the values around 2 to see what the function is doing. Well, I noticed that at 1 the function value is 5, and I noticed that at 3 the function value is 7. So if I split that difference at 2, it should be 6. We don't know for sure. We can check. The way we can check is substitute values that are a little closer to 2 than 1 and 3. In terms of getting close, 1 and 3 are very far away, even though we're not used to saying that just being one whole number apart is very far. Alright, so what I want to do is I want to change the values of that table. So I want to activate it on the table. So okay, sorry for the pause. Couldn't tell what I was doing here. I want to edit the table settings. So start at 0. I want the table, well, let's start this actually at 2, so that I want the number that I'm starting on. And table step, I'm going to change that to, the first was 0.1. I want it to count by 0.1. So that way the table is going to give me 1.9, 2, and 2.1 right here and right there. So I know at 1.9 it's 5.9, at 2.1 it's 6.1. That I can be reasonably sure that at 2, as x gets closer and closer to 2, it's going to get closer and closer to 6. And I don't need to go any farther than that to really be pretty confident about that. However, we can go further. Some functions, due to the steepness of the graph, you might have to go farther to check that out. So I'm going to do that one more time. I'm going to go to Table, Edit Settings. I'm going to change that to 0.01 or 1/100th. I'm going to go back. So, and I'm going to do that one more time so that we can start the table at 2 and I won't have to scroll 100 times to get there. Alright, so I have 1.99 and 2.01, and my answers are 5.99 and 6.01. Alright, so we're only differing by 2/100ths, and that, again, we can be reasonably sure that as x approaches 2 from the left side of the graph, from this way, and from the right side of the graph, this way, that the function's value, f of x, is approaching 2. And that is the case. So the idea of the limit, remember, is that it's the intent of the graph, what it's going to do, and estimating limits from graphs and tables. Well, we can make a table of those values you already saw. You can make this table by hand and just plug in the numbers. So for instance, if you wanted to, and you were doing this by hand, you could say 1.9 squared plus 2 all over, and calculate that, and do the same for 2.1 and see what you've got. So that's what we're doing, and that's going to kind of lead to the next concept. So that is the basic idea of a limit.